Wait, what? The Earth is actually flat, haven't you heard? Kidding! Roses are red and planets are spherical. It's something we kind of take for granted for 2,000 years, thanks to the ancient Greeks. In fact, the vast majority of objects in our solar system are spherical, from the sun to planets and moons. But have you ever wondered why the planets look like this? Why are they basically spherical and not, say, cylindrical or cube-shaped? Well, that's because all objects experience self-gravity, a force which pulls their atoms towards a common center. Once a planet, or maybe a moon, accumulates enough mass, its self-gravity will pull it into a sphere-like shape. The universe's bodies formed after the Big Bang exploded about 13.8 billion years ago. Tiny dust particles circulating in enormous donut-shaped dust clouds began to collide. If the collision was gentle enough, according to NASA, the dust particles fused. Collision after collision created a snowball effect. The more mass a budding planet accumulated, the more its gravity grew and the more matter it attracted. That gravity pulls all the matter toward the center of gravity. It's like the kitchen sink. All water will flow through the hole in the bottom. In the case of planets, every piece of matter is trying to get as close as possible to the center of gravity. Planetary bodies will continue to shift matter around until they find an equilibrium, a state in which every point is as close as possible to the center. And the only shape that achieves this kind of equilibrium in space is a sphere. But round doesn't mean that every planet is a perfect sphere. Their shapes are scientifically described as oblate spheroids because they all bulge slightly around the middle, like a basketball that someone is sitting on. This means that if you walked around the Earth from the North Pole to the South Pole and back, you travel about 39,931 kilometers. But if you walked around the equator, you travel 40,070 kilometers. Pretty close to a perfect sphere, but not quite. That's because the circumference of the Earth's equator is 24,900 miles, 40,070 kilometers. As such, when you stand at sea level on the equator, you're farther away from the center of our planet than you would be at either pole. This bulge is a result of rotation. All objects experience self-gravity, a force which pulls their atoms towards a common center. As the mass of an object increases, so too does its self-gravitational pull. After it exceeds a certain mass, the pull gets overpowering to the point where the object collapses onto itself and becomes spherical. Little items, like say a banana or a lug wrench, can resist this fate because their self-gravity is relatively weak, allowing them to retain non-spheroid shapes. However, in planets, suns, and other truly massive bodies, the force is so strong that they can't avoid being distorted into spheroids. But gravity is not the whole story. The oblate spheroid shape is the result of a battle between gravity and rotation. While gravity tries to render planets spherical, the speed of their rotation tries to squash them. The faster a celestial body spins, the more disproportionate the equatorial bulge gets. Think of a merry-go-round. When it's whirling around quickly, it's hard to stay on at the edges because centrifugal force is pushing all the outermost mass away. Translate this concept into 3D, and it's what makes a planet's equator bulge. Since the planets rotate at different rates, they're all different shapes. Just look at Jupiter. Earth is only 0.3% wider at the equator than it is from pole to pole. But Jupiter's measurements showcase a much bigger disparity. Indeed, astronomers have found that this plus-size planet is a full 7% wider at its equator than it is between the poles. On some other planets, this bulge is even more pronounced. Saturn is the most non-spherical, squashed planet because it's spinning fastest, being more than 10% thicker around the equator than around the poles. After all, a day on this gas giant is a brisk 9.9 Earth hours long. In contrast, the Sun, with its immense gravity and very slow rotation, is almost perfectly round. A significant percentage of stars in the sky rotate much faster and bulge noticeably at their equators. One such star is Altair, located just 16.8 light-years away from our home planet. It's among the brightest objects in the night sky. Altair is also notable for spinning very, very rapidly and completes a full rotation on its axis every 10.4 Earth hours. Accordingly, astronomers estimate that Altair is at least 14% wider at the equator than it is from pole to pole. Other forces act upon the stars and planets as well, altering their shapes. Although Earth is an oblate spheroid, it certainly isn't a perfect one. The gravitational pull of the Sun and Moon both influence the planet's shape to a degree. For that matter, so do Earth's own plate tectonics. Consequently, the mass of our home world isn't evenly distributed. In fact, it's rather lumpy. Still, it looks a good deal rounder than Jupiter and Saturn. In turn, the planets in our universe appear way more spherical than some of their moons do. Mars, for instance, has 2 small satellites, neither of which has the self-gravity to be pulled into an oblate spheroid. Instead, their appearance is often described as potato-shaped. Although the universe teems with spheres, many bodies in space aren't even remotely spherical. Asteroids and comets can come in any shape, altered by crashes and interstellar spinning. Mars has a potato-shaped moon called Phobos. In fact, only about 20 of the nearly 300 known moons in the solar system are the familiar round shape we expect. The rest are more irregular. The reason for all these non-spherical bodies: their lower mass means they don't have enough gravity to even out their shape. Anyway, it's pretty handy that the planets are spheres. If they were tetrahedrons or toruses or pentagonal prisms, it would be much trickier to make a solar system model. Hey there, thanks for watching. If you enjoyed unraveling the mysteries of our spherical universe with us today, don't forget to hit that like button. It tells us you want more stellar content like this. And if you haven't already, join our space journey by subscribing to our channel. We've got tons of exciting explorations ahead, and we'd love for you to be a part of our community of curious minds and space enthusiasts.